Alrighty. Number 11. Write an equation of a line perpendicular to y equals 4x plus 1 and contains 8, negative 3 in slope-intercept form. First thing you need to recognize is the slope currently is 4, and then the slope of a perpendicular line needs to be the opposite reciprocal of that, which would be negative 1 over 4. To write the equation, we start with the slope-intercept formula, which is y equals mx plus b. We're going to replace y with the y value from the point that they gave us, which is negative 3. Replace m with negative 1 over 4. And we're going to replace x with 8. 8 is from the coordinate that they gave us. So the only thing that doesn't have a replacement is b, which stands for your y-intercept. So we need to find the y-intercept so we can write the equation. To find b, the first thing we have to do is multiply negative 1 over 4 with 8. So negative 3 will be equal to negative 2 after you multiply, plus b. Then you would need to add 2 to both sides of the equation. When you add 2 to negative 3, you're going to get negative 1 is equal to b. So now I have my y-intercept, and now I can write the equation that they're asking for. Y is equal to negative 1 over 4x minus 1 is my final answer. Number 12 is just like number 11. So currently the slope is negative 1/3. So the perpendicular slope, again, has to be the opposite reciprocal. So that means positive 3 over 1, or just 3. So again, I start with y equals mx plus b. This time I'll replace y with 4, m with 3, x with negative 15, and bring down plus b. Alright, so I will have 4 is equal to 3 times negative 15 is a negative 45. And then I would add 45 to both sides, and I would get 49 is equal to b. So y is equal to 3x plus 49 is the final equation. Number 13, if AD is the perpendicular bisector of GM, which statement is true? So since AD is the perpendicular bisector, we need to show that it is perpendicular by adding the right angles. We need to show that it bisects GM by adding the tally marks between GT and TM to show that those two pieces are congruent. Based on the perpendicular bisector theorem, any point on the bisector is equidistant to the endpoints. So that means GA has the same distance as MA. XG has the same as XM. And DG has the same as DM. Because all three of those points, A, X, and D, are on the bisector. So they're all going to represent congruent pieces. So this one with this one, let me give it a double since I've already used single. These two and these two. Okay, so since you know it's a perpendicular bisector in advance, the best thing to do is mark everything that you know, the right angles and whatever congruent parts that you know. And then come back and answer the questions. So which statement is true? Statement 1, T is equidistant from from M and G. That is correct. so that's true. Statement 2, angle ATM is a right angle. That's true. If you need me to highlight it so it stands out, I will be more than happy to. Here's ATM. Okay. And then X is equidistant from G and M, which is again true because X is along the perpendicular bisector. So since all three are true, the answer is C. Number 14 says angle E is 2x plus 29. You might want to add that to the picture. No. Or I'll just draw an arrow. All right, 2x plus 29. T is 6x plus 5. These represent the base angles of the isosceles triangle PET. So since they're my base angles, remember that base angles are congruent, so let's give them an arch. Also, base angles are directly across from the congruent sides, so let's give those congruent sides the tallies. All right, now it wants us to find the measure of the vertex angle. The vertex angle is P. Okay, but this is definitely a multi-step process. We have to find X first, substitute it back in before we can find P. So let's get started. To find X, we're going to take 2x plus 29 and equal it to 6x plus 5 because those two angles are congruent. Then I would subtract 2x from both sides, so that I would get 29 is equal to 4x plus 5. Then subtract 5 from both sides, so I would get 24 is equal to 4x. Then divide by 4, so 6 is equal to x. And now that I know what x is equal to, replace it in both angles, or just one, because you know they're the same. So I'm going to do it inside of t. So that's 6 times 6, which is 36, plus 5 is going to give me 41. So this one should also be 41. Now, what do I know about all three angles of a triangle, folks? They all add to equal 180 degrees. So I would take 180 minus 41 minus 41 again to get my angle measurement P. And in doing so, I would get 98 degrees is the measure of angle P. All right. Number 15 is a lot like 14. It's talking about an isosceles triangle, but there's no picture, so it might be helpful to draw the picture. So draw yourself the best triangle you can. Label the vertices, CAT. All right, it then says CA is congruent to TA, so let's mark them congruent. So right away, I know which angles are congruent as well. Those are going to be my base angles, and they are angle C and angle T. See how knowing all the vocabulary is very helpful. It tells us C is 4x plus 5. And T is 5x minus 10. So again, the process is very similar. We're finding the measure of angle A this time. Again, the vertex. So set them equal to each other. 4x plus 5 equals 5x minus 10. Subtract 4x, you would get 5 equals x minus 10. Add 10, you would get 15 is equal to x. And now substitute x back into the base angles. So 5 times 15 is 40, no, that's too small. 5 times 15 is 75. 75 minus 10 is 65. So each base angle is 65 degrees. With that being said, 180 minus 130, because 65 and 65 make 130, would give me 50 degrees for the measure of angle A. That's supposed to be an equal sign. 50 degrees equals the measure of angle A. Make sense? Good. Number 16. Write the theorem or postulate that proves triangles congruent. If the triangles are not congruent, write none. So there's 5 ways to prove triangles congruent. We talked about this in Unit 4. The first one being side, side, side. Second, side, angle, side. Third, angle, side, angle. Fourth, angle, angle, side. And lastly, HL. So if the pictures aren't showing one of these 5, you have to write none. Let's get started. So for the first picture, NP is congruent to PM. So that's a side. I have 2 right angles, or a right angle per triangle. So that's an angle per triangle. And then they share this side right here. So that's another side. So side, angle, side. For the second picture, N is congruent with L. JK is congruent with MK. And then don't forget about our good old vertical angles. So there's a pair of angles there. So we have angle, angle, side. The side would have to be between the 2 angles to be angle, side, angle. Since it's not between, we have to say angle, side, angle. I'm sorry. I just contradicted myself. Erase. It's supposed to be angle, angle, side. Again, because the side is not marked between the 2 angles. Continue. For the next picture, I have a side with 1 tally, a side with 2 tallies, and then don't forget about the shared side. That would get 3. So side, side, side. On this one, S is congruent with U, T with itself, and then the shared side. So I have an angle, angle, side with an angle, angle, and a side not in between. So angle, angle, side. Any questions? (17) tells us MQ measures 0.9. MP is 2.9. M to N is 1.8. Based on this information, what theorem or postulate could we use to prove triangle MPQ is congruent to NPQ? All right. So first of all, we know the total distance from M to N, and we know part of the distance. So if I take the part from the total, so 1.8 minus 0.9, I would end up getting 0.9 again. This is 0.9 as well, so that means these 2 are congruent. I have my shared side that is congruent. So far I have 2 sides. And then I have a right angle on the right-hand side, and I have a right angle on the left-hand side as well. So two sides with an angle in between would give me side, angle, side, based on what I have right now. But if you look a little deeper and think a little deeper, because I have a right angle and because I'm showing that MQ is the same distance as NQ, that implies that PQ is a perpendicular bisector. With that being said, it wants us to find NP. So since PQ is a perpendicular bisector, MP is congruent to NP. So NP is equal to 2.9 as well. You need to understand all of that information. Alrighty, for number 18, it says triangle GIJ. I'm missing the G at the top of my triangle. Forgive me, Lord. But there it is. So GI is this side here, is congruent with GJ, this side here. IH and JK are medians, which means from H is a midpoint of GJ. So since H is a midpoint of GJ, let's add two tallies here. These two are the same. Since JK is also a median, K is a midpoint. So that means GK and IK are the same. But and even further beyond that, you know that this entire side is the same as the one on the right hand side. So these two little pieces will also get double tallies. Okay, since the entire side is the same as what's over here. It says what information oh my goodness, there's a lot of typos, could be used to prove that triangle IPK is congruent with triangle, it's supposed to be JPH, I'm sorry, by angle, side. So this is supposed to be H. All right, so far, let's highlight those two triangles real quickly so we can see it. This is IPK, and this is JPH. It's supposed to be JPH. So far, we know that IK and HJ are congruent, right? So for angle, side, we need two angles to be congruent. So we don't need to know about A, PI, and PJ. We don't need to know any more sides. It would be helpful if PKI was congruent to PHI. So these angles here is what they're referring to. That would be nice. It would also be nice to know that IH and JK are angle bisectors. So that would be good. Now, currently, on my picture, you see angle, side, angle, right? Well, there's another set of angles that we can never forget to mark anytime we see them. And you should catch on to where I'm going right now. But if not, you should recognize KPI is vertical with HPJ. So that's how it would be possible to have two angles and the side not in the middle because of that vertical angle. So we already have the vertical angle. So knowing B by itself would be enough information, or knowing choice C would be enough to answer the question. Okay. Number 19. Which side links below could form a triangle? We tested over this with Unit 5. And the shortcut is take the two smallest ones. So this one is small and this one is small. Add them together, 24 plus 20, and check how it is if it's greater than the largest one. So this is the largest. Okay. 24 and 20 give me 44. Is that greater than 30? Yes, that's true. So this is a triangle. All right. For the next section, I'll pick a different color. The two small ones are 3 and 4. Check to see if it's greater than 9. 3 plus 4 is 7. Is that greater than 9? No, that's false. So this is not a triangle. So you catch my drift, you should be able to finish the next two by yourself. That's easy. Number 20. If Mr. Treadway leaves home and travels 8.1 miles northwest, then turns right for 3.2 miles, how many more miles would he have to travel to get back home? Hint, use the triangle inequality theorem. In other words, find the range. To find the range of possibilities, you need a minimum and a maximum. To find the min, you take the two numbers and you subtract. So 8.1 minus 3.2. To find the max, you add 8.1 plus 3.2. And then I'll grab my calculator after I set it up. .1 plus 3.2 is 11.3, and I'm going to copy that and change it to a minus, and you get 4.9. So the range is written as 4.9 less than x less than 11.3. So as long as the answer falls within that range, then it's possible. Okay. I know this question doesn't seem to be worded correctly, but this is the way we're going to solve it if we see it. Hint, hint, wink, wink. So for number 21, same type of problem, just different numbers. Again, find the range. So the minimum would be 20.3 minus 4.6. The maximum is 20.3 plus 4.6. So I could do it in my head, but I don't feel like it right now. So 20.3 minus 4.6 first. Let's copy it down. Change it quickly to a plus. So 15.7 less than x less than 24.9. And we're going to pause right here for another brief session.